The Department of Highways is considering building motorways between Town A, Town B and Town C. 3 options are being considered. Option 1 involves a motorway connecting Town A and Town B only. Option 2 involves a motorway connecting Town B and Town C only. Option 3 involves both of the motorways in the previous options, plus a bypass around Town B connecting the 2 motorways. All motorways are expected to have a 50-year life. The Department of Highways always uses a discount rate of 7%. Determine which option should be selected using benefit cost ratio. Right, so here's our data that tells us how much everything's going to cost. So you can see it costs a lot more to put the freeway in between Town A and Town B than it costs between Town B and Town C. Putting the option 3 in, that involves not only the part between Town A and Town B, but also a bypass in the middle, so it's going to cost a bit more than both of them put together. Okay, so the Department of Highways likes to use benefit cost ratio for determining whether their projects are viable, so let's do that. So we'll start out with, for option 1, we need to work out what is the present value of the benefits. So we've got operating cost, annual benefit and salvage value. Now we need to consider the operating cost in as a negative benefit and not as a cost in the denominator, because this is money in the future. In benefit cost ratio, we're only interested in how we can stretch the money we have at the start. So therefore, the capital cost is what we're going to consider as a cost. So our benefits for option 1 is equal to, well, first of all, we have our annual benefit minus our operating cost. So that's going to be 12 million minus $4 million. We need our factor to bring it to a present value. So we said our discount rate is 7% and we said our project life is 50 years. So this is going to be multiplied by 1.07 to the power of 50 minus 1 divided by 0.07 times 1.07 to the power of 50. So that deals with our annual cost. We also have our salvage value that we get in the future. Now this $30 million is made up of all of the earthworks that we don't have to repeat when we rebuild the road at the end of its project life. Now that is a benefit, so it's going to be plus 30 million, and it's a one-off payment, so divided by 1.07 to the power of 50, which gives us 110,405,970 for the capital part, for the annual part, plus 1,018,433 for the salvage part, which gives us a total of $111,424,403. So now we need to work out what is the benefit cost ratio for this option. So it's going to be 111,424,403 divided by the capital cost. Remember, we're only using the capital cost because we use this to find out how much of our budget that we have to spend this year should be used. So when we do this division, we end up with a benefit cost ratio of 1.11. Sounds good. We should put in a freeway between A and B. Now let's look at option 2 and see if it's worth doing that. So benefits for option 2. Well, it's basically the same formula, but different numbers. In this case, we're only getting $5 million worth of benefit, but it's costing us $2 million to get that benefit. So it's going to be 5 million minus 2 million. Once again, we've got our factor. Now the discount rate is the same and the number of years is the same. So it's going to be 1.07 to the power of 50 minus 1, all divided by 0.07 times 1.07 to the power of 50. As before, we need to be concerned about our salvage value. So that's all the earthworks we'll have left over. So that is going to be $20 million. And once again, it's a one-off payment, so we divide it by 1.07 to the power of 50. So the annual amount comes to $41,402,239. The salvage value as a present value is $678,955. So that gives us a total benefit of $42,081,194. So we need to work out the benefit cost ratio for this project. So the benefit cost ratio for project 2 is equal to $42,081,194 divided by $50 million. This is not looking good, because when we do the calculation, we'll see the answer is only we'll see that the answer is only 0.84. So this project is not worth doing. So option 2 is a bad option. Its benefits are not as large as the costs. However, it might be that doing B and C together with A and B is worth doing. So we need to consider that. So let's look at option 3 and see if that works. Right, so now we're going to consider option 3. So the benefits for option 3 are equal to, once again, we're going to take our annual benefit of $20 million minus our annual cost of $7 million. We need our factor, and our factor will be the same one we had before, of 1.07 to the power of 50 minus 1, all divided by 0.07 times 1.07 to the power of 50. So that gives us our benefits, our present value of the annual benefits. We also need to consider the salvage value. So we have plus $60 million. Once again, it's a single payment, so it's going to be divided by 1.07 to the power of 50, which gives us $179,409,702 plus, for the salvage part, $2,036,866, which gives us $181,446,567. So we can work out our benefit cost ratio for project 3 is going to be equal to $181,446,576 divided by our capital cost, which is $170 million, which gives us 1.07, which is bigger than 1, so it's worth doing this project. Now, we can compare this benefit cost ratio with the benefit cost ratio we had for the first one, and you'll see that the benefit cost ratio for the first one is bigger. But that doesn't matter. That is not important. What is important is, was the extra amount that we built for this project worth building? What we should be working out is the benefit cost ratio of the difference between option 3 and option 1. So if we calculate this, we get the benefit cost ratio of project 3 minus project 1 is equal to, well, first we need the benefits from project 3. So we said that was this number here, $181,446,567, minus the benefits from project 1, which we calculated earlier, and we found were $111 million, $424,403, all divided by 170 million minus 100 million which gives us a grand total of 1.0003. Now, this value is larger than 1, so that means we can go ahead with project 3 because the benefit we get of project 3 above project 1 gives us a benefit cost ratio of 1.0003 over the cost. However, this number is not much bigger than 1. It's pretty close to 1. So therefore, whether we actually go ahead with it will depend upon other things. The error in this number is much larger than this little 0.0003, because if we look at these numbers, they're all 1 or 2 significant figures. Down here we've got 5 significant figures. So really, this is equal to 1, and it's borderline whether it's worth doing the project or not. So what will happen is we'll consider other political factors when we're deciding whether we should do this project. In fact, if we change our discount rate by just a small amount, we would find that it would not be worth doing.